sorry for the delay. Various Sankhya Paddhatis used in literature. So they are mainly Bhuta Sankhya, Katyayani Sankhya, and Aryabhatiya Sankhya. Without any delay for this. So, one question that can arise is why do we even need these systems? You could just write it with numerical symbols, or you could just call it Ekam Dve Trini. So, why do you need it? Does anyone know the answer?
Maybe like, see, that time there were no written books, they used to tell it in verses. So if this was the form of some poem, it was easier to communicate. So maybe.
Yeah. So mainly that's the point. It is easier to memorize with devices like Chandas that will help you to remember verses quicker. So we'll start with Bhuta Sankhya, and unlike what is shown in the image, it does not mean ghost. So let's get started with some examples. So when I say hands, what number is implicit?
5 to 10.
2 hands.
Oh, 2.
When I say eyes, again the number 2 is implicit. When I say eye, 1 is implicit. So this system uses this trick to encode numbers. So we look at some examples. Dash Deva. How many Devas do we have in our philosophy? Dash Aditya. Aditya, sons of Aditis.
Dwadash Aditya.
Yeah. Dash Veda. Right. Dash Nayani. Dve. Yeah. Dash Angulya. Anguli is finger. So 10. Yeah. So this is the essence of the Bhuta Sankhya, and it is a compound word. Bhuta plus Sankhya. Bhuta is object, Sankhya is count. So when you use the implicit numbers associated with your object to encode, it's called Bhuta Sankhya. So some standard examples, we walk through some of them. Generally, we consider Akasha, Ambara to be 0. Shunya is again 0. And Adi is 1. Rupa is 1. Brahman is 1. Dve, as we discussed, Netra, Ayana, Hasta, hands, we have 2 hands. Yeah. 3, Guna. So in our philosophy we have Triguna, Satvik, Rajas, Tamas, and Rama. It's not just Rama, we have Parashurama, Rama, Balarama. So that is why Rama is associated with 3. Veda is 4, Rig, Yajur, Sama, Atharva Veda. Yugas are also 4, Satya Yuga, Treta Yuga, Dwapar Yuga, Kali Yuga. And there are Bhuta is associated to 5. We have Panchabhutas. And Prana, again we have 5 pranas. Pandavas, as the name suggests, 5. Bana, in our philosophy, the Kamadeva has 5 arrows in his sheath. So Bana is associated with 5. 6, we have Rutus, 6 Rutus, 6 Rasas, Shat Darshanas in our philosophy. And 7, we have 7 days, 7 Vasaras. 8, we have Ashtadikgajas. So 8 elephants, we believe there are 8 elephants guarding each direction. And now again, another interpretation is to have Navarasas in certain texts. It's not mentioned here. So Dasha, we have a lot of things. Dashavatar, the common avatars of Vishnu. Anguli, Dasha, Angulya, 10 fingers. Pankti is also 10. Disha, direction, we have 10 directions in our philosophy. Yeah.
Questions? Up and down.
Yeah, so
Up and down.
It depends on the context. Sometimes it means 10, sometimes it means 8, sometimes it means 4 also.
So we'll look at 2 up applications of Bhuta Sankhya in literature. So the first one is decoding, encoding the value of pi in hours. So this is taken from Kriya Kramakari, composed and it is attributed to Madhavacharya, mathematician. So let's read it out. Vipuda Netra Gajahi Hutashana Triguna Veda Bhavarana Bahavaha Navanikharva Mite Vrati Vistare Paridhimanamidam Jagadur Buddha. So Vibuddha means Devas. We have 33 Devas. Netra, 2. Gaja, if anyone recalls from our slides, was 8. Ahi is also 8. Hutashana, anyone wants to guess what is Hutashana?
What is Ahi?
Ahi is a snake, Naga. So 3 is 3 as mentioned. Guna, Satvik, Rajas, Tamas, so 3.
Hutashana.
Hutashana is also
Fire.
fire. Yeah, there are 3 types of fire. Tejas and there are 2 more. Yeah, Pa is 27. Varana is 8. Varana is also elephant. Bahu, we have 2 arms. Nava is 9. And Nikharva is 10 to the power 11. That is a standard notation in literature. Sometimes it's a billion. In our case, it's 100 billion. So if you arrange the numbers and you have to flip them. So once you read it left to right and you encode the numbers, you have to flip them right to left. So so Bahava had 28 and Vibuddha 33 it's in the end. So and Paridhi Mahanamidam, Paridhi is circumference, and you are supposed to divide the first number by the diameter, that is Navanikharva, so that is 900 billion, and if you divide it, you will get this number. I just plugged it in a calculator and this was the number I got. And if you Google what's the value of pi in Chrome, you can see that it matches digit to digit. It's quite surprising. So there's one more verse, and it is not exactly a direct representation, rather it is a series representation. For those of us who have done Fourier series, this will be a recall. So Vyase Varidi Nihate Rupahate Vyasa Sagara Vihate Rishara Divisham Sankhya Bhaktavranam Swam Pratak Kramat Kuryat. So this is a procedure to get your series representation for pi. So Vyasa is diameter, Varidi is 4, Nihate is multiply.
Can
So-
somebody guess why is Vadidi 4?
4 oceans.
Yeah, 4 oceans. So you multiply your diameter. You multiply your diameter by 4 and then divide it by 1. Rupa is 1. Anyone wants to guess why? Why is Rupa associated with 1?
Rupa, like Brahman or something.
Form. You only have one form. So Sagara is, anyone wants to try why it's 4? And you multiply to this 4 into the diameter, you divide it by 3, 1 by 3, and 3 Shara Vishama Sankhya. So 3, 5 and so on, odd numbers. Vishama is odd. And you divide 4 into diameter by these odd numbers in alternate fashion. Runam is subtract, Swam is add. So you do this in alternate fashion and you will get a series that looks like this. So suppose Vyasa is x is your diameter, Paridhi circumference is y. Then y is stated to be equal to 4x times 1 by 3 minus 1 by 5 plus 1 by 7 minus 1 by 9 and so on. So, and by definition y by x is y. And you have pi by 4 is 1 by 3 minus 1 by 5 plus 1 by 7 minus 1 by 9 and so on. So for those of us who recall, this used to be the Fourier series of the step function. So moving on, we have
It's not audible. Use my working. It's not letting you use.
change the back.
So today we will also see another type of Sankhya Paddhati which is called as the Katapayadi Sankhya Paddhati. There is a sloka related to how the letters are encoded according to the Katapayadi. The Vyanjanas are taken and every 10 Vyanjanas are taken into one bracket and the process repeats, like for example ka kha ga gha nya cha cha ja ja nya is one set, and then we have ta tha da tha na ta ta da tha na which is another set, and pa pa ba bha ma is another set. So it is seen there, and it is similar to the periodic tables which were originally created by the Octavian periodicity, which was thought before the earlier stages before the modern periodic table came about. So the Prakriya is only the consonants have value. The vowels or the ajantas, they are not used here, and only the consonants which are used, and the independent vowels have no value. We can easily map every word into a sequence of numbers from 1 to 10. That is the specialty of this. Instead of going to beyond 10, we can only curtail it to up to 10 numbers. For example, when we say Gaja, in this we can see that Ga is 3 and Ja is 8. So Gaja does not become 38, but it becomes 83 because we have to reverse the numbers which in the order which is seen. The same example you can see Ramayati 2516 can be written as 6125. And an interesting fact is Adi Shankara's birth date was decoded based on the Katapayadi Sankhya itself. And we write Shankara. Sha is Ya, Ra, La, Va, Sa, Sha is 5. Ka is 1. And Ya, Ra is 2. So when we reverse this, we get 2, 1, 5. So the 2 represents the month, the Vaishakha, and 15 represents the day in the Vaishakha, or the 15th day of, it represents the 5th day of the Shukla Paksha. One is Shukla, and so it's Vaishakha Shukla Paksha. This is how the Sringeri people have found out his date of birth based on the Katapayadi Sankhya also. And even Carnatic music, especially the system which was created by Venkatamakhi, who is considered as one of the greatest musicologists. He gave a system to list out the Melakarta ragas in Carnatic music. as we know, there are 7 swaras and 72 melakartas. And the first half has, the melakartas are divided into 2 parts. One which have the Shuddha Madhyama and other which have the Pratimadhyama. So the Shuddha Madhyama ones are 36 in number, and the same goes for Pratimadhyama also. For example, when we look at Dhira Shankara Varanam, the colloquial name is Shankara Bharanam, but in order to encode it into Katapayadi, they have added the word Dhira Shankara, Dhira before the name Shankara Bharanam. As we can see, Dhira can be written as 92, and when we flip it, we get 29, which is the index of the Melakarta in this scheme. 29th raga in the list of the Melakartas is Dhira Shankara Bharanam. Even Todi, for that matter, the colloquial name being Todi, the official name is Hanumat Todi. The Hanumat was added in order to fit it into the list, because Ha is 8 and Na is 0, 10 being 0. So when we flip it, we get 08, and Todi is the 8th raga in the Melakarta scheme. In this way, Venkata Makhin created a very systematic way to list out the Melakarta ragas, in contrast to other schools of music. And as we saw earlier, there are other methods to decode the value of pi. Like, for example, Bhadram Budhi Siddha Janma Ganita Shraddhasma Yat Bhupakihi. The same manner, when we take the numbers for, according to Katapayadi Sankhya and reverse them, we get 3.14, 15926 and etc. The required value of the pi. In the same way, Gopi Bhagya Madhuvrata Srungi Sodathi Sandhiga Kalajivita Khatava Galahala Rasanthara. The same way, when we do the similar analysis for this verse as well, we get the same value for the pi.
Do you know the source of the second one? I also seen it but could never find the source. Anybody knows?
Like, it is a fairly recent one.
I think so, yeah. But still who has, it's a clever, even if it's recent, it's a
And
clever
even
way
the
of encoding.
encoding part is slightly different because it's going from right to left. Instead of
Ankanam Mamato Gati is like traditional Sanskrit word is Ankanam Mamato Gati. You have to read all the words from letters from numbers from right to left.
Even Katapayadi was used to list out the predict the position of moon in the sky. We know that there are 12 Rashis and each Rashi has 30 degrees. So in total we have 12 into 30, which is 350 degrees. And this text, Chandravakya, has provided the exact positions up to the minute scale, which is a great achievement given the equipment they had in those days. We can see the values which they have tried to encode. And so that's it.
Yeah, fine. So we saw there are 3 main number systems. So firstly, this number system came up because say like there were several astronomical and mathematical works in India. So say you want to tell the value of pi, or say you want to tell the distance between Earth and the Sun. So firstly, everything was written in the form of verses. So in Sanskrit verses, how many people here are aware about Chandas? Say 2-3 people. Yeah, so basically in Sanskrit, if you want to write a verse, the verse has to follow a specific arrangement of Guru and Laghu Akshara. So Guru is the long vowel, Laghu is the short vowel, and that's what gives the rhythm to Sanskrit verses. So that is like a very strict constraint. The constraint on the number of letters itself is strict, and further you have to match the long vowel and short vowel. So you have to fit the words that way. So it is very difficult to write everything. So if I want to write say 314, standard way would be write Trini Shatani Chaturdasha cha. But that will maybe not fit in the meter. So what people used to do is use these techniques. So the first was Bhuta Sankhya, which used words like objects instead of numbers. So instead of having to write Trini, I can use any object which is universally known to be three, like gunas. Say, what else did we have? Rama, because we have three Ramas. Then Agni, because there are three holy fires to be done. So that was one way. So Bhuta Sankhya was like the way people started with. So instead of numbers, I use things which are commonly known. So yeah, let me ask some questions. If I use the word Dashana, what will that mean? Dashana. No, not Darshana. Dashana. Yeah.
10?
It's not just Dasha, it's Dashana.
Why?
Yeah,
Like Darshan.
yeah, right. And Dashana, due to that reason only, Dashana is the name given to teeth. So Dashana means 32 because teeth are 32. Like it's a well-known fact. So instead, wherever they will have to write 32, they will instead say Dashana Mitaha or just Dashana. Like they will use this word as a number, and that works. So we saw in the Vibhuda Netra Gajahi Hutashana also that he very smartly encoded the entire large number using just words. So Vibhuda, and one rule is we go from left to right. So that's the general rule to be followed in all number systems. So Vibhuda is Devas, so 33, Netra is 2, so 2, and you write this in the opposite way. So it is Vibhuda, then Netra, Gaja. Gaja is elephant, so Diggaj. There are 8 Diggajas. So Gaja, Ahi is Naga. So Naga, there are 8 Naga Lokas, I think. The number 8 is associated with the snakes usually. So Ahi, then Hutashana, Hutam Ashanam Yena. So the one that burns. That burns the food that is given to it. So Hutashana, so 3, because Agni there are 3. Then Hutashana 3. Guna is again 3. Veda is 4 because there are 4 Vedas. Bha stands for asterism. So there are 27 nakshatras. Nakshatras are called Bha. I think I don't find an example now, but yeah. So nakshatras are 27. So 27 you will write in the normal way only. 27, not 27. In the opposite. Bha. Vadana is again elephant. Elephant are 8. Baha, Bahu is 2. So this one, this whole thing is the diameter of a circle, is the circumference paridhimanam of the circle whose diameter is 9 into 10 power 11. Navanikhadva mite vritti. Vritti is a circle. So if you divide this by 9 into 10 power 11, you will get pi accurate to the 10th decimal. As we show over here. So right, so if he wanted to write this big number using the numbers, like what is this? Crores. Starts with Nikhadva, I think, then Khadva, no. Arbuda, Koti, no, Koti is over here. So like very large number, no way to encode it in shloka. Similarly over here, then yeah, and this actually, those who said who know Chandas, can you recognize the Chandas of this verse? So Chandas, you see, there's a rhythm. Vibhudanetra gajahi hutashana triguna veda bhavarana bahava navanikhadva mite vritti vistare paridhimanamidam jagadurbudha. Anyone who knows the name of this? It's Dhruta Vilambitam.
Sorry, what bit is that?
Dhruta Vilambitam.
Oh, okay.
Yeah.
I've heard only of the 8 main chapter.
Yeah. These are like still they are like the Rudabila rhythm is like fairly. Similarly, this one also. Here, like the maths is a bit complex, like specifically because in Sanskrit, when you have several synonyms of addition, several synonyms of subtraction also. So runam over here, this runam means to subtract. Swam means to swa is self, so to make it oneself, so to add it. Yeah, and that's how we get this infinite series for pi. And this was done by Madhavacharya in like 11th century, maybe earlier, 13. Yeah, then came this Kattapayadi, because even say that pi also we saw, the first line of the entire verse was just objects. So even objects can take up multiple letters. We want to do something even faster. So they came up with Kattapayadi. So in Kattapayadi, the encoding is very simple. Like this is something we do in English language also. Like when we were kids, we used to write coded messages using this, then just decode by mapping each and every letter. So this is a similar thing. So Kaka Gaganga 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, this is the verse that defines the system. Fine. So this way we can encode anything into words and also decode any word into a number. So say in some verse you know that it has been encoded by Kattapayadi and you saw the word Gaja written over there. So we'll just see Ga and Ja. Ga is over here 3 and Ja is over here 8. And you will decode it in the reverse order. So first Ja then Ga. So 8 and then 3. So 83 is the number represented by Gaja. Similarly for the so one thing is what swara is connected is not relevant. Also, if there is a half letter which is not connected to the swara directly, you will not consider it. So over here Akashat. So obviously we will go from left to right. So first is the half, like the with halant. This the will not give any number. Only if it is connected to a swara, it will give a number. And swara alone will also not give a number. Like it will give 0. If only swara is used, it will give 0. So I have the, so it will be so nothing for the. Then sh is ya, the, la, va, sh. So this is how the name also comes. Kattapayadi. Ka, ta, pa, ya. These 4 come in the adi. So the one column is nothing but ka, ta, pa, ya. This is why it's called Kattapayadi. So it's easier to remember. So if I want to say what is sh, so sh is over here 5. Then ka is obviously 1. So 5, 1 and a. So a swar without a consonant will give you 0. 5 and 0 is the number over here. Yeah, let's do some example. Say the word is Prabhu. Can you all decode what number this might be representing? You can use this table if you want. Not 32, 41. 42. So you will look at the letter which is connected to the swara. So in pra, it is actually pa plus ra plus a. So the letter connected to the swara is ra, not pa, and ra is 2. So bha is 4, right? Yeah, bha is 4 and ra is 2, so 42. Right, so this is how we can decode using Kattapayadi. Yeah, any doubts still Kattapayadi? And in fact, that's what is used to name all, index all the ragas of Karnataka music. Any doubts still Kattapayadi?
I had doubt in that 5, those 2 shlokas were there, no, for 5. I mean, how they exactly different.
How are they different?
Yeah, on the last slide of this.
This one?
No, the pi. Definition for pi. In the
I think in Kattapayya.
Gopi, the
Okay,
Gopi.
okay.
Yeah.
That one, the Gopi.
Yeah.
How is it
Here you
different?
don't, here it is, right?
Yeah, so in this verse you won't flip. Here, like this is like a fairly recent verse, and here you go from right to left to right. So this is 3, 1, 4, 1, 5, and so on. Yeah, they are giving up till 32 places of decimal place. I think Sadharatna Maharaja, written by Shankar Varman, is the latest one. So actually the thing is, Madhavacharya, who gave that infinite series for 5, also said that that infinite series is not fastly convergent. Like it is not converging very fast. So you need to calculate a lot of terms to get the exact value. And that's why he gave 3 other formulas which were more better converging. So now only thing that you have to do is sit and calculate all the series till however accuracy you want. And yeah, till however much accuracy you want, like you have to sit and calculate. So actually Shankar Bhagavan was also not a descendant, but like in the Shishya Parampara of Madhavacharya. So, and he was in fact the last most influential, like the one who wrote something in maths. So in Sadharatnamala he gives, I think, 25 places of decimal places. Something like that's the so I mean, now the technique was known. You just have to sit and find till however many places you want. So
It might be a silly question because I'm not. What do you mean by recent? Like in this context, how is it recent?
recent, I am not sure. See, Madhavacharya was in 13th century, so surely after 15th. Wait, Shankar Varman was in 17th century, if I remember correctly. I'm not sure. I'll have to. So yeah, and another thing is Chandra Vakyas. Like if you just look at these Vakyas, Gir Nahashriya. He is like Vani, the Saraswati Devi. Naha is ours, Shreya, like our well-being. So may Saraswati be for our well-being. Dhenavaha Shrihi. So cows are Lakshmi. Like they are wealth. So all these are like, what is this? Just some casual statements. What is this? Dhanvan Putraha. Son is very rich. Yeah, so what does he mean? So this also we otherwise wouldn't have known. It's because of the commentaries that were written by people following him that we know, okay, so if you decode this according to Kattapayadi, you get the values in minutes, degrees and Rashi. So Rashi is 30 degrees. So that was the angle, the system for angles used in India. So if you just decode these, you get these numbers, and these are the rising points of the positions of moon in the sky. So yeah, I also don't know what exactly does this mean, but yeah, up till the precision of minutes, and it was given in the form of like easy sentences that you can just remember. So yeah, the main thing was at that point paper was rare, so you have to compress as much as you can. All the previous works are specifically done in sutra, so you don't even have to waste even a single letter. Yeah, like there was a thing called like even if they are able to reduce the length of the text by 1 letter, they will feel the happiness of child born. So it was like
एकमात्र लाघवेन पुत्रोत्सव मन्यते
एकमात्र लाघवेन पुत्रोत्सव मन्यते
वैयाकरण.
Vaiyakarana. Okay, yeah. So the grammarians when they write. So basically, it was true for any sutras. All sutras are specifically written to write it in concise. So this was another thing. Now came Aryabhatta. So Aryabhatta, as we know, he did many things. He gave value of pi. He was before Madhavacharya. He was in 499 CE, and that's when he wrote his magnum opus Aryabhattiya, which is the like it's all so many things, and he starts it with so the after the first shloka, which is the Mangal shloka, second shloka itself, he defines his own number system. So his number system is something like ka, kha, ga, ga, ga. You will represent all the numbers from 1 till 25 till ka to ma. So all the vargakshara. Ka, kha, ga, ga, nga, cha, 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 nya. These are called vargas. So ka varga is ka, kha, ga, ga, nga. And all of these 5 vargas, ka, cha, ta, ta, pa, ka, cha, ta, ta, pa, are called the vargiya vyanjanas. So all these vargaksharas are given numbers from 1 till 25. Then you give numbers, here is 30, here is 40, here is 50, 60, 70, 80, 90, 100. And furthermore, so see, the main problem is, he is writing a work on astronomy. Astronomy has, like, the basic thing will start with, Yuga is 4,32,000 years, 43,20,000 years. Now, you see the number of zeros, and if you want to, even if you want to write it in Katapayadi, you will have to write 5 letters which for zeros. So na 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 na. So it might be even difficult to form a meaningful word. So Aryabhatta did something intelligent. So he said, okay, I don't want the words to be meaningful. So the idea in Katapayadi and Bhut Sankhya was the words should be meaningful. So easy to remember also, easy to decode also. He said, I don't want to have meaningful words. It's fine if I get meaningless words, but it should be according to a rule, and that rule is this. So A means 10 power 0, A and A both mean 10 power 0, E and E mean 10 power 2, U and U mean 10 power 4, 10 power 6. So A, E, E, U, U. Then in Sanskrit there is a Ru and a Dirgha Ru also. Then there is a Ru and a Dirgha Ru also. So both of them will be 10 power 8, then A is 10 power 10, O, I, O, I, O. Right. And
any reason why I and O are switching places here?
oh wait.
A, I, O,
Oh, I think it's my mistake. Like it should be A, I, O.
Is this correct?
This is correct.
I think so.
Okay. I'm not sure
I remember
why.
in class also when Aditya sir taught this same confusion. So,
Okay.
it's correct.
I have no idea. There might be some reason. Yeah, and see, mostly these are not used, like they are 10 power 10 till 10 power 16, so very rarely used. I'm not sure, I haven't seen the usage of these words, these letters in whatever I have. So yeah, and now the rule is somewhat different. So now if you want to write any word, you have to attach it with a swara. So swara alone will not mean anything, and also vyanjana alone will not mean anything. And when swaras and vyanjanas are combined, you have to multiply them. So if I say ka and a, it means 1 into 10 power 0. So you can see he is coming up with the kind of scientific notation of India. So say if there is a word called Bhanu, like there won't be any such good word. Like meaningful words are very rare in Aryabhatiya system. But say this is a word. How will you decode this? So it is
20.
bha in A. Bha is
24.
24. And A means 10 power 0. And Na is 20
20.
20.
into U is 10 power 4.
4.
Yeah. So this is my number. So now I can write it 1, 2. This is the number represented by such a small word. Right. And this time, if you have Sanyukta Akshara, so conjunct letters like say Prabhu again. Now both of these letters you will add them. So pa and ra, value of pa and ra will be added. So what is pa? Pa is 21, ra is
40.
40. So 21 and 40 whole multiplied by 10 power 0 because only a is there. And bha is
24.
24
Into 10 power.
into 10 power 4. So 2, 4, 061, something like this. Right. So the main idea is now words won't be meaningful, but I can safely encode even large numbers by this technique. And there might be even more than one way. So as he gives one example over there also, numau yah. This numau yah. So if I write numau like no and ma together, so ma is over here 5, ma is over here 25. Both of them together I can call them 30. So yah. Like he's just giving an example in this verse.
Is this kind of compounding allowed grammatically?
No, grammatically there are several things which won't be allowed. Like, it's not that it's not allowed.
Is this a valid Sanskrit sentence? Or
Yeah.
like it's allowed because of
you see such kinds of compounds in grammatical texts specifically, because
Even
there they
Pali
also give all
Sutras
sorts of these results. So yeah, like in grammatical texts such compounds are found, but in like classical Sanskrit, when you are using Sanskrit, you don't find this compounds.
So what does this verse say?
This verse is just saying how to write this. So again, the interesting part is you can see varge again. So varga is like, he has nicely used the words over here. Varga also means these first 25 letters which are called vargiya vyanjanas. Next, all others are avarga vyanjana or avarga akshara. The first 25 are varga akshara. Varga also means square. So at a constant power of at a squared power of 10. So all the even positions. So say I write something like this. The first position is a squared position, like it is a power of, it is an even power of 10. Then this is an avarga, then this is a varga, this is a avarga, and what he means to say is all the avarga vyanjanas will represent the avarga letters. So avarga vyanjanas are from here to her. So 30, 40, 50. So you can see all of these are having a number only in the avarga place. So if you want to write them over here. So like he's basically just giving a method to write numbers. Like it's fine. What I explained, if you understood that, then this is enough.
Okay.
Yeah, good. So, so this is the very next verse after this. Yugalavi bhaganaha kyugru shashi chaya giyi nushu chudru ku nishi bulru shkru prak shani dhumvidgva guru ki chubha puja bhadli nukru rugu buddha sauraha. So you might have seen that verse in the poster. Makhi, Baki, Paki, Naki, Naki. That was also because it was encoded in Aryabhatiya. So when you encode in Aryabhatiya, this is what happens. You get words like Kyugru. What does it mean? Means nothing. But you have to accept it because you want to work with numbers. So okay, fine. First example is Kyugru. What is Kyugru? Kha is 2. Ya is 30. Whole multiplied by U is 10 power 4. Then Gha is 4. Ga, Kha, Ga, Gha, 4. What is Lu? 10 power 6. Like A, E, E, U, and Lu. 10 power 6. Now if you write it, this is 4 into 10 power 6. Over here you get 32. And then 4 zeros. 43,20,000 is the number of years in a yuga, Mahayuga. And that's what he's saying, Yuga Ravi Bhaganaha. So in one yuga, so in a Mahayuga, it's understood, the number of Bhagana. So Bhagana, it comes from somewhere else, but for now, just understand Bhagana as revolutions. So the number of revolutions that the sun makes in one yuga. Ravi is sun. So again, here the revolutions mean the revolutions and not the rotations. Like not day night revolution, but the revolution due to seasons. that is Kyugru. So 43 lakh 20,000. Obviously, because 43 lakh 20,000 years are passing, so 43 lakh 20,000 times the sun has revolved around the earth.
You said Bha was nakshatra also, right?
Huh?
Did you say Bha was nakshatra?
Yeah, Bha was nakshatra, and Bhagana comes
Maybe-
from how
maybe
many
the
times?
maybe the
Yeah,
sun
so,
is going
so
on
when the
20.
sun revolves around the earth, it is basically moving through all the Bhaganas once.
All of us.
And yeah, so Bhagana is basically a term used for when
the wrong movement.
any heavenly body completes one revolution around the earth throughout the background of all the stars. Yeah. Right. Now, then Shashi is the moon. So how many revolutions does the moon do? Can somebody calculate? Right answer. Yeah, let's see who does first. I'm also trying. Oh,
Which part is he writing?
yeah, this is what I got. Did somebody try?
From which part of the
Huh?
uh,
Jaya Gi Mushu Chru.
okay.
So yeah, again over here that Ru is not the letter Ru, like it's not the Swara Vara Ru, it is L plus Ru. So Ch and L and Ru. So see the thing, this is easier because he has given it according to the way we write. So first all the 10 power 0 because no the Swara connected is then he has connected E, so 10 power 2. Then U, so 10 power 4, and Ru, so 10 power 6. So yeah, that's how you get that it should be 10 power 6 and not 10 power 8. It's not Ru, but it's Ru. And yeah, so Cha is 6, Ya is 30, He, so Ga is 3, Ya is
30.
again 30. Like they are written by the offset of 2. Then
Ra is 5.
Mushu, so Nga is 5, Sha is 70, Cha is 7, and La is 50. So that's all. And these are the number of revolutions that the moon does. Now let's tell. So who is Earth? Who is a synonym for Earth? And Earth does these many number of revolutions. Shani, Saturn does 1,46,564. Jupiter does something. Mars does something. Kuja is Mars. And Bhrigu, Buddha are same as Buddha. So Venus and Mercury have the same number of revolutions as the Sun because they are the interior planets and they move with the Sun.
So what is the time frame?
One Mahayuga. 43 lakh 20,000 years. Right. So this was just, see, you can see in the second verse he just defined his number system. Third verse he is using his number system in its full force. And yeah, thanks to commentaries written by Bhaskara 1, Aryabhatta 2, Bhaskara 2, that we are able to understand this. Otherwise, like even
In the Nishi, who, the A you have to ignore, right?
it's not A, it's Rana. So Bhagana, you can see that Rana and that Rana is similar.
Oh, it's Rana.
It's Rana.
Oh,
Yeah.
okay.
I specifically put the image of the manuscript itself so that you can understand how people actually read this. So again, they have to see, okay, here also Rana is in this font, so this might be Rana and not A.
So it is Nishi Buna. Or like what?
Nishi, Boom, Ru. Like Rana and Ru.
Okay, Rana is half na.
Yeah.
Half na, okay.
Yeah. Yeah, so here they have to use Ru because the number is large, like it's going 2 decimal places. Yeah, and coming to the words that was there in the poster, the Makhi, Bakhi, Pakhi, Naki, 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 has just Kaki, Kish, Gush, Kaki, Kikwa, Lucky, Kigra, Hakir, Haki, Kichas, Gush, Jug, Mak, Lap, Tapacha, Kalal, Tachaha. This was the words. So any sane person will just think that this person has gone insane. Yeah. Without commentaries, obviously, even we can't understand it. It might just seem that some baby is trying to write letters, but they all have a meaning. And if you decode them according to this, so Ma Ki is 225, Kha is 2, E is 100, so 200, Ma is 25, and 224. And what are these? So these are the difference in R sign values. So the thing is, the sign that we use, sine, cos, wala sign, that actually comes from the Jya that was given by Aryabhatta. So again, how we get signs is, say I have a circle. This is my radius. This is some angle. I want to calculate the sine theta. What do? We like by going by the definition. This is the value of this is R. So this will be R sine theta, right? Right. And this, the formula for finding this R sine theta given the radius and angle was given by Aryabhatta. So he called it Jya. So the thing is, if you extend this completely, this looks like a dhanush, right? And that's like the bow. And that's how this was like in any mathematical text you will find this is called the dhanuhu. The length of this arc is called dhanuhu, and this is like the rope which is used to tie the bow and arrow. That's called Jya in Sanskrit. So this was Jya, this was Ardha Jya. So from this Jya and this Jya in several of the Indian dialects, it becomes Jiva. And that Jiva later when Arabics learned maths from India, this Jiva got converted to Jeva. And when later this was translated to Latin or Greek, I don't remember, they took Jeva, like instead of taking Jeva as it is, they translated it. So Jeva means pocket, cavity. So word for cavity in Latin is sinus. So that's how they came up with the word sine. Yeah, and that's how we got it. So again, so in Indian thing, the one thing which was common was instead of reporting the sine theta, because the decimal point systems wasn't used much in India. So even if you saw in the pi verse, he never said 3.145. He just gave a big number and said divide it by 9 nikharvas and you will get the value of pi. So the thing was, people were more comfortable with whole numbers than decimals. So instead of reporting the sine theta, and sine theta is always less than 1, so you can't write it in only integers. So they had a circle with a radius of 3438, which was the standard circle. So you can see over there 3438, the sine 90 degree. So 3438 is the value of R, and then whatever sign they want to calculate, they will insert calculate R sine theta. And then say I want to find a circle with a radius say 10,000 or something. What will you do? We will just take the ratio because this will just linearly scale. So that's how this R sign was in use. And here also, so what Aryabhatta did was he made a table and gave the value of all the signs. So obviously sign does not have a closed form representation. Like it's not like just add these numbers, multiply and you will get the value. Sign is like a transcendental function, right? So he gave the values for every interval of 225 minutes of this circle. So R sign of 225 minutes, then R sign of 450 minutes, and so on. So as you can see over here, so 225 minutes is the same as 3 degree 45 minutes, then 7 degree 30 minutes, 11 degree 15 minutes. And to compress it even further, what he did was, instead of saying the value, he just said what is the difference between two consecutive R signs. So the first one is 225 minutes. Yeah, the modern value is 224.856, so it was like fairly accurate. Then the next is, the difference between the next two is 224. So you add 224 to 225 and you get 449. So 449 is the R sine value for 7 degrees 30 minutes. And so on. So all the way up till 3438, which is like 90 degrees, one full circle. Right. So this was the math. So again, use Aryabhatiya number system to encode the entire sine table into just one verse. So if you want to recall the sine table, say sine of 30 degrees or something, you only have to remember this one verse, makhi pakhi and all, and you will get it. Later, in fact, Bhaskara the first also gave a very good approximation of the function sine, of the rational approximation of the sine of any angle. So you just give an angle in degrees and you put it in that function. It will give you the value of sine accurate till like the fourth decimal place. Yeah. So this was one thing. Yeah. Any doubts still here, like in any of the number systems? Fine. So let's go to something which is not number system. Okay. So the Knight's-Stool problem. So does everybody know about Knight's-Stool problem? What is the Knight's-Stool problem? Anybody who does not know? Okay. So the Knight's-Stool problem is, so everybody knows chess, right? So say, I'm not making the entire chessboard, but understand. Say I have this board, and you know the knight can move 2 steps in one direction and one step perpendicular to it, right? So from here, the knight can move over here or over here, something like this, right? Now the question is it possible for the knight to start at some point, then move throughout the chessboard, covering all the boxes without coming to the same box twice? That's the question, Knight's-Stool problem, and it's a very famous problem. Like even in West, it was solved like by many people. So the idea is, okay, in 3 cross 3 it's not possible only because you cannot reach the central position. Say we go to 4 cross 4. Like I hope everybody got the idea, right? So say I start from here. From here I went over here. Then from here I went over here. Then I went over here. Now I went over here. So here, then here. Then there. Like I went over here. Now I'm stuck. Like I can't go over it. Like all the places are blocked. So this is the Knight's-Stool problem. So can you traverse across the entire chessboard, covering all the boxes and not going on any box twice? So this was the problem. Now, do you see any knight over here, any chessboard over here? Anything even closely related to? Even the verse is like nowhere saying any knight or ashwa or anything. What does it mean? And the interesting part is, so this might seem like, okay, a play of words. It's a good play of words. So it's in Vidyanmala meter. So Sena, Lili, Lina, Nali, Lina, Nana, Nali, Lili, Nali, Nali, Lena, Lina, Lili, Lina, Nana, Nali. And this has a meaning. So this is the meaning. I, a truthful, well-read man, a leader of a group, helpful to servants, praise the army which has as its leader a man who praises playful persons. So, like this might seem slightly non-trivial. In English, this sentence seems a bit Shakespearean, but yeah, in classical Sanskrit, this is like a regular meaning, right? And yeah, so how this meaning comes up, don't ask. I don't know. Like I can tell you about some words. So a man, the word for the man is Nru. And Nru, so it's a Lukaran word in Prathama Ekvachan. Just like Pitru becomes Pita, Nru becomes Na. So one of these Nas might be meaning this man. Then say truthful, so Ali means false. And so Ali means false. And Nali means truth. So the one who is truthful. So some of this Nali might be meaning that, and so on. Like all this is. So there are several verses like this that use only one letter throughout, that use only 2 letters throughout. This might seem like something of that sort. Chitra Kavya. These are called Chitra Kavya. this might seem something like that. And if we were there, we would, so this was written by Rudrata. And if we were there, we wouldn't have even went a step further about it, like, okay, apart from this meaning, what does it mean? But there is a commentary by Nami Sadhu, and that commentary has this verse. Now this verse has absolutely no meaning. Kasha je naga bhattaya tadha kheveng raghabe shaje thade pache methe dona sachala de phame. This does not mean anything. Yeah, he explains it in the next verse, in the commentary's next verse. So what he says is, you can, so this contains all the Vyanjanas from Ka till Sa. So 32 letters are there. So just write them in a box and replace them with numbers. 1, 2, like Ka will be 1, Sha will be 25, no, more than that. Something, like you just make that table. And whatever the number is there, you go to that number. So you will start with Ka. Then from Ka you go to Kha. So Kha is over here. So one place to the down and 2 place to the right. So it's moving according to the knight's tooth, like according to how a knight moves. From Ka go to Kha. Then Ga is again 1 step up, 2 step to the right. Ga. Then Gha is again 2 steps to the right, 1 step below. So Gha. And you will see that all the numbers are sequence of the points where the knight should go. The knight is the valid moves of a knight. And yeah, since it's covering the entire verse, so a verse has 8 letters in each pada. There are 4 padas, so 8 in 4, 32. There are 32 numbers, so he is solving half the problem. If you know half the answer, you can know. Okay, fine, I'll come to that later. Now, how does this verse relate to that? So the interesting part is, so you know this verse, say na li 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 na na li. Now let's go according to what position he has shown. So from say, from this first position, you need, from this position, you need to go over here. First position to third position. Because Ka and Kha is over here. So say na, and then from Kha to Ga. So na to over here. And let's move along that path. So say now. So this animation will continue moving along that path. For now, trust me, it's the same path as it is given in the verse. And you just look at the letters which it is covering. Okay, so say na li 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 na na li. Did you get what the words made till now? It's the same as the original verse. Say na li 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 na na li. Then again, li na 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 le na li 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 na li na li le na li na li 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 na 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 li. We did a knight's tool and we got the same verse. And okay, so now if you know the solution to this verse, like you stopped there, you stopped over here, right? Now, if you want the complete solution, what will you do? Just write this verse again. So again, write say na nali. So from here, you will again come over here,
Same.
and it will be the same as above. So again, the same route. So once you got the solution to half, like 32 squares, you just have to extend it to 64 squares, and that's the entire chessboard. So the knight's tool problem solved using this. So solved might be like, obviously if he is encoding his verse in the form of a knight's tool problem, so knight's tool problem might have been solved even before him. He just used it. Yeah, and
I have a doubt. So this can be done even without using the words at the bottom, right? Because I'm hoping that when going from say to na, there is only one unique na.
no,
which
there
I
is not a one unique na. There are more na. So
I mean, which a horse can reach.
So
is it not the case?
yeah, no. So say na, I tried that.
Okay.
So from here, actually na has 2 leaves to go.
Yeah.
One is over here and one is over here. If you go over here, you will get stuck. Like I tried and I got stuck. So So this is the only correct
So if you
one.
know the answer, you will get back the right.
Yeah, and this is how the horse will move, and yeah, you get another verse, the same verse. Yeah, I think there is one verse by Vedanta Deshika where you go in this way and you get another verse with a different meaning.
The next verse. The
Yeah,
next
the
verse.
next verse in that text. So you just go through the knight's way path, you will get a different verse.
So is there any modification to this verse which gives an automatic path? You know of any?
Like I did not.
So basically you're showing me that there are two leaves possible from Na. So was there any
Oh,
modification
that,
to this original verse which makes it
I'm not
unique?
sure. I don't know.
No, this is like a palindrome. So when you have a palindrome, you can read backwards and forwards. This is a palindrome in the Knight's solution.
Right. Yes, sir.
That is, if you read according to the Knight's solution, you will get back.
Okay.
Yeah, and in
So
fact,
that is why it's
Yeah.
the Knuth, K-N-U-T-H, Knuth, he was so impressed by this that he made a similar palindrome in English also. You can search for it. Like, not a palindrome, like, made a similar box for English. Like, it does not have letters, but it has words in each of the boxes. And when you go through the path, you get a different meaning also. Yeah, you can look that up. Yeah, that's it for today. So yeah, now we have a quiz, a short quiz, where you can just exercise whatever you learn.
You can scan the QR code.
Do we need some antidote or can we just I think it's gonna take time. Can we skip the meditation?
You're writing
Oh, okay. Like that.
So I've all scanned the QR code.
and you just solving like a rigid ball and swords. Ball is also flexible.
So it's not. So the rules for the quiz are simple. So the first few questions will be single words. For that you will have to decode them using all three sheets, Sankhya, Katabehari and Aryavatya. And then you will have to concatenate all the numbers you got from each system. Make sure to switch your number right to left after doing the initial encode. And each question you will have 60 seconds. And the last few questions are phrases. For that you will only have to encode it in one stream that has been stated in the question. 60 seconds to answer each question. Yeah. Let's start.
Is it working for everyone?
It's not working.
Huh?
Algorithm to like discrimination
Network?
Internet.
Oh.
Yeah, right.
this is using Bhuta Sankhya, right? Maybe you can tell which scheme to use to decode which.
Bhuta Sankhya, Kattapayadi, Aryabhatti, that sequence. You'll have to decode using all three. Seven was Bhuta Sankhya, and then three is 0 in Kattapayadi, and re, you'll have to take re, not the. So, 2, yeah, 20. So, and then you'll have to do the. Three, I think
Three is mountain, so there are 7 mountains. Like in the Vedic literature, there are 7 great mountains. So, like mountain is usually synonymous with 7. Next. So Vibhuda means devas. So Vibhuda Deva, so first Bhuta Sankhya is 33, then V is here now 4, so towards the end like you should see a 4. Yeah. From the,
Yeah.
there is 9.
Yeah, Tha is 9, Ba is
3.
3, so
Ba is
4, 3,
9, 3, 4.
9, yeah, 9, 3. Just increase the time to 3 minutes, it should be.
Okay, fine, you all can start solving if you want. The expert is something.
Yeah. Let's start. course. So Samudra, there are 4 Samudras, and Sa is 7. Yeah, 7. Ma is 5, and you have to take Ra, so 2. So it becomes 7, 5, 2. So 4, then 2, 5, 7. Then Sa is again until Ma it's 25, then 30, 40, 50, 60, 30, 80, 90. So Sa is 90, Ma is 25. So Sa is 90 into 10 power 0. Mu is 25 into 10 to the power 4, and you'll do a similar calculation for Sa and get the last sequence. We are running short of time. I'll skip some questions then. Everyone's ready? Yeah, in order to hear you are. sure to swap your number after it. Titi, we have 15, not 30. So, Pratama to Chaturdashi and Amavasya, so 15, not close one. Yeah. Devanshi is there. That's all for today. Thanks for joining.